So thank you for joining. This webinar and demo is for the launch of our new Squonk2 product that is replacing our Squonk computational notebook product, which is going to be phased out at the end of this month. We refer to this as Squonk2, but that's more of a sort of generic name. There are a number of different components which we will see in a minute. Let me go to slideshow. So these are our objectives in the Squonk2 universe, which are actually exactly the same as our objectives in the previous product. That hasn't changed. It's just the approach to achieving this that has changed. And the audience for Squonk2, as ultimately the audience is, of course, our users, who would be lab scientists, cheminformaticians, and computational chemists. But also of interest, it would be also of interest to people like project managers who are wanting to make tools available to those people, and for IT coordinators who are having to make those tools available. And also for tool developers themselves, people who are writing software algorithms that predictive models and all sorts of things that they want to be able to make available to users easily. They would certainly be interested in what we can do here. So Squonk2 is a reasonably complex application suite. But we have put a lot of effort into into how to deploy it. A little bit more on that later. But what this means is we can deploy it in a number of different ways. The evaluation site, which we're going to be using later for the demo, is obviously the main one that we talk about. But we can also manage additional deployments hosted by us, and you'll see an example of that in case study 1. And we can deploy to customers' own infrastructure. Typically, this is cloud infrastructure. Though strictly speaking, it doesn't have to be cloud. We would typically manage it on the customer's behalf, and the example there will be seen in case study 2. And the business model is we want to provide cost-effective access to computational tools, which is always a challenge for particularly for small organizations, small biotech, small CROs. The cost of accessing the software tools is all too often prohibitive. And there's a lot of open source, publicly available tools, but making those accessible is difficult. And that's exactly what Squonk2 does. You can use it in evaluation mode for free. It'll always remain free in that mode. The limitation there, if you want to think of it as limitation, is that all your data is public. So your evaluation is done when everyone else can actually see what you're doing. If you want to keep your data private, we have other options for that. As you use Squonk, I'll use the term Squonk now generically for Squonk2 and the components. As you use it, typically the main compute and resource utilization is handled by job execution, which we'll see later, and data storage. And that we account for and monitor and roll up into what can be thought of as an account in a sort of a virtual currency, which we call Squonk coins. Now, if you want to have private data and you want to have higher levels of quota and service, you would need to access one of our subscription tiers, where we have bronze, silver, and gold, which have increasing levels of quota and service. That's all assuming you're using our evaluation server. But we can also deploy an environment to your dedicated environment or a cloud-hosted environment for you at an agreed fee. And the other aspect, which will be coming on down the line more, is we're trying to create a marketplace for access to computational tools. So these Squonk coins that you accrue by running jobs, if you're a provider of a job that has high intellectual property value, you can actually charge and get some payment for use of that through use of through users accessing your tools within Squonk. So within Squonk, we have an organizational hierarchy to let you organize your work. At the top level of this is something we term the organization. You can think of that as a company, but it's up to you to use to do this in whatever way you want. Under the organization lives an organizational unit, or a unit in short, and that could typically represent a research group or research project, but again, you can divide it up however you want. And then within the unit, you create projects, and that's where you do your work. And essentially, a project is a bit of file system where your data lives and where you can work on that data. And the data in one project is kept separate from the data in another project. So individual workers can create projects in their own, what we call personal unit, within an organization which we refer to as the default organization. So this is for sort of a user working on their own, not really having big needs to collaborate within groups and things like that. If you were a company or a research organization, you would probably be using organizations and units. The access control is done using Unix-based systems, so it provides very strong access control so that people in one project can't see the data from another project unless you've given them access to it. And that sharing, that giving of access can be done either at the project level or the unit level. And the access can be read-only or read-write. So if you don't trust your boss to to change your data, you can just give them read-only data if they want to see it, and similar for your colleagues. And the usage, that's these Squonk coins that get applied when you execute jobs or use storage. These accrue at the project level, but is accounted for at the unit level. So it's the owner of the unit who picks up the bill effectively, but the data is accrued at the project level, so you can see exactly who's doing what at a very fine grained level. The architecture of the application is like this. This is significantly simplified, but we have two what we can call back-end services or back-end applications: Squonk Data Manager and the Squonk Account Server. Data Manager is basically where the science goes on. Account Server is basically where the business goes on. So the Account Server is where your organizations and units and things are defined and where the accounting is done. The Data Manager is where you manage your data and you run your jobs, you run your applications. Those are all accessible through REST APIs, and they communicate with each other through a REST API. Sitting on top of that is a web application, which we refer to as the Data Manager UI, because it's mostly representing functionality from the Data Manager, but it also accesses the Account Server. So strictly speaking, it's more than just a Data Manager UI, but it's convenient just to call it that. So the back-end applications are Python, Flask applications. This all runs on a Kubernetes environment. So our only dependency is to have a Kubernetes cluster, which means we can run pretty well anywhere, certainly including all the major cloud providers, but also on premises as well, if you can provide us with a Kubernetes cluster. And as I said, we've got a number of deployment tools to make deploying and managing these environments relatively straightforward. And we've got about, I think about 5 or 6 of these deployed in different places, some on the cloud, some on premises. A number of links to the documentation, so you can go and look at that, to the sort of the design documentation, and to those data manager and account server APIs. So you can go and look at those. And these slides will be made available after the event. Now, how do you do your work? That's primarily through two things. One, by running applications. And the only application we have at the moment is Jupyter Notebooks. Then we may add other ones in the future, but by allowing us to run a Jupyter Notebook gives a huge amount of flexibility in doing pretty well whatever you want, either through a terminal or through a Jupyter Notebook. And it's well established. A lot of people know how to use these. And the key thing is that the Jupyter Notebook, when it gets fired up, it has access to your project's data. So here in the Jupyter Lab interface, you're seeing in the File Explorer here, all the data in your project. So you can just instantly fire up a Jupyter Notebook and start working on your project's data and start creating new data in it. We'll show you Jupyter running in a minute, so we won't say anything more here. More interesting or more diverse are jobs. So jobs are basically a shrink-wrapped bit of computation that is packaged up in a way that can be very easily executed within Squonk and within the context of your project. So you choose from a list of jobs. Here we're showing one for calculating some molecular properties. This one is using RDKit, but we also have ones that use CDK and Chemaxon. And so you choose to run that job. You get a user interface auto-generated for you, allowing you to specify your inputs, your outputs, your options, and things like that. And then you run the job, and you get a detailed report of the job executing and completing, or failing sometimes. If it fails, you've got access to the logs, so you can work out why it fails and things like that. So jobs can be very simple, like these simple property calculations, but they can also include complex workflows. So we have some virtual screening workflows for docking and things like that are in themselves workflows. We use the Nextflow workflow system for executing these, and these jobs can be parallelized across the cluster and can be very compute intensive. But basically, a job, like an application, has access to the data in your project and can work with that data and generate new data in that project. These jobs emit events that you see in the user interface, and they emit costs which accrue to Squonk coin usage within your project. Again, we'll demo this in a minute. So I'll just highlight two case studies here where we have people using Squonk. The first is a chemistry CRO. I can't name them. They've been using the Squonk Notebook, our previous product, for several years now, and they're in the process of switching over to Squonk2. And the key benefit for this organization is the ability to distribute computational tools to their users, which is something they've found very difficult to do. Some of the tools are too expensive to distribute to the whole community, and open source equivalents would be more attractive. And some of them are just deploying them across their organization just turns out to be a complete nightmare. And just by dropping those jobs into Squonk makes their lives so much easier, and makes their scientists, gives their scientists access to these tools. And these tools are sometimes very simple. They're just predicting those sorts of molecular properties we saw earlier. Sometimes they're a bit more complex. They might be running predictive models or other things. And they use this to distribute. Some of the stuff is open source, some of the stuff is commercial, and some of this is in-house developed by them. Case study 2 is the Diamond Light Source, where we've been working with them for a long period again, and they've been using Squonk2 for quite a long period now. And they use it as basically a job execution engine for their fragment screening follow-up software called Fragalysis. So at Diamond, the fragment screening program can now generate huge amounts of data, and the analysis of that data has really become the bottleneck. The idea of turning those fragment leads into drug discovery leads has become the bottleneck. And as part of that, they want to be able to do computational analysis, virtual screening, drug design, other things. And rather than create a whole new system for that, they decided to hook into Squonk. So they primarily use the APIs of Squonk. They don't use the user interface that much, though obviously it is available should they want to do something more specialized. But essentially what we've done is we've embedded job execution within the Fragalysis environment. So users can very simply say, right, okay, I've got these two fragments, run this job on them. It calls out to Squonk, runs the job using the REST API, pulls the data back in and lets them analyze it. So makes something that really is quite complex appear very simple for the user. And we're almost finished here on the slides. So the current status is we're now launching, as of today, the Squonk2 suite. You can think of it as beta status. There is more to be done, but it is a state that it is ready to use, and we're certainly ready to start getting feedback on usage. What you can do is register for an account. That'll give you access as an evaluator, so to the evaluation projects. If you want access to the tier projects, contact us, and we'll sort that out. At the moment, we don't have payments mechanism in place, so we can't automatically charge for these bronze, silver, gold tiers. So we need to come to some agreement on that. In time, we will be implementing that, so that will become much more seamless. And of course, contact us if you've got any questions, ideas, or specific needs. And finally, as I mentioned, this isn't a done deal yet. We're still actively working on this, and this is some of the things we will be working on over the coming months. So we'll be adding many more types of jobs, particularly some predictive models and things in that area, particularly more things in the virtual screening and drug design area. For now, we're going to stay primarily in the domain of cheminformatics and computational chemistry, though there's actually nothing technically stopping us moving out into broader domains as well. We need to sort of finalize the accounting and the billing side of things, which I just mentioned. We want to create a new sort of companion product. This will be a sort of a third module, which we're calling Squonk2, which is designed for analyzing data more. So the data manager is great at running jobs or applications to generate data, but if you want to analyze it and visualize it and explore it, we're going to create a new tool called Squonk2 for that, which would be quite a neat and exciting way to actually visualize this sort of data. And finally, we want to put in place a more comprehensive workflow builder, a bit like the one that was present in the Squonk notebook, allowing you to sort of drag and drop jobs together and execute them in sequence, a bit like KNIME or Python Pilot. We haven't prioritized that so far because we can put in complex workflows as jobs themselves. What we can't do is just at the moment is allow users to design them on the fly. And that's what the workflow builder will do. So that's the end of the slides. As I said, we'll make those available. What I'll now do is switch over and actually do a live demo. So this is where it all goes horribly wrong. So this is the Squonk Data Manager UI. So as I said, this sits over the top of the data manager and the account server REST APIs. So there's a bit of documentation here. You can see guides on the concepts involved, the guided tour, how to do various things. So there's a reasonable amount of documentation here already in place. What we're going to do is we're going to start using it, and I'll show you the different aspects that we mentioned. So the first thing I'm going to do is I'm going to log in. In order to log in, I need to log out. So Login, which takes you to our Keycloak authorization and authentication system. If you're a new user, just click on the register link, and that will take you through the standard, register, you get an email, you confirm it, and then your account is set up. That will set you up as an evaluation user. So I'm already set up, so I log in. Now we'll click on this settings button to get the what we call the context. So, as I mentioned, we've got an organizational hierarchy. At the top of that is the organization. So we've got the default organization, where typically sole users, individual users will operate. We're going to jump into the Informatics Matters organization, and you can see here a number of projects that are within the Informatics Matters organization. We can filter them by unit if we want. Let's not do that yet. So we've got a number of projects here. These are actually all owned by me. But you see, this one's an evaluation tier. This one's bronze. This one's bronze. This one's gold. And you've got the usage that has been accrued by this project over the past, what we call billing interval, which will be the last month. And it tells you a few things like how many instances used, so that's how many jobs you've run, the amount of storage you've used up, what the allowance for that tier is, and so this tells you how much of your quota you've used up. If you want more details, you can drill down and you get a list of exactly all the jobs you've done and what the cost of those are. So what I'll do is I'll go into this launch demo project that I set up earlier, and I've already got a few things in here ready to demo. So the place we'll start is on the Projects tab, which is basically a representation of your file system for that project. So this is a very basic file explorer, letting you just explore the contents of your project. You say you can have directories, you can put files in there. There's nothing particularly unusual here. We now switch to and obviously you can upload and download data from your project to get data into your project or get data out of it so you can use it elsewhere. So on the Executions tab, you get a list of all the applications and all the jobs that you can execute. So the red ones are jobs, the sort of the bluey grey ones are applications. Let's first look at Jupyter. So let's fire up a Jupyter notebook. Jupyter demo. And we say, what sort of type of Jupyter notebook do we want? Do we want one for data science? Do we want one with TensorFlow installed? We'll just go for a minimal one. You can specify to an extent how much resource you need, both in terms of memory and in terms of CPU. And we'll now run this. And now what's happening is a Jupyter notebook is being fired up in a Kubernetes pod running in the cluster. And we click on the instance here to see it on the Results tab, which is where you see all the results of your executions. So this application is now already running. We can click Open. This will take us to the Jupyter Lab interface. And as you'll see here in the Jupyter Lab sort of file explorer, you're seeing exactly the same contents as we saw in the project. So the Jupyter notebook here that we're going to create will have access to all of the data, making it very easy to do one of two things. One, you can just open a shell and start hacking around in Linux if that's the sort of thing you want to do. Alternatively, more likely, what you'll want to do is to fire up the Jupyter notebook itself. So that notebook has now been created. You can give it a different name. You can just say print hello, and then execute it. So it's a bog standard Jupyter notebook, but it's got access to all the data in your project. So we won't dwell on this anymore. Anyone who's familiar with Jupyter will will know what's involved here. More interesting are some of the jobs that we can run. So if you scroll down here, you'll see we've got quite a lot of jobs already here, and it's relatively easy to add new ones. We'll look at that briefly at the end. So let's look at a job. Let's find one that calculates molecular properties. So we'll type in mol props, and we've got this one here that we actually saw in the presentation, which is the RD-Kit molecular property calculator. So we say, right, and this filtering is done based on tags that we apply to each of these. So they're fairly flexible. If you typed in properties, you would actually, well, let's do it that way. Properties. Here we get a much larger number because a lot of these calculate properties. So you'll notice some of these are not enabled, the Chemaxon ones, because you need a license file. We have a mechanism where you can put your license file into the system where it is only accessible to you or your project or your unit or your organization, what is appropriate to you. So these Chemaxon ones, because you need a license file, they're not enabled for all users. Once you've uploaded your license file, then they become enabled. And what we're going to do is look at the RD-Kit one, as we mentioned. So click on it, and the user interface for running the job gets shown. Now this one is actually quite a neat one, because the two ways where we can specify these the inputs. We can and we will specify them from a file that contains smile strings. But just to indicate the sort of flexibility we have, we've got the ability to fire up a chemical sketcher. So you could, if you wanted, just start sketching your molecule and then create a list of molecules that you want to calculate, and then execute the job. We won't do that. In the benefit of time, we will select them from a file. So we've got a file here that has 10,000 smile strings in it. So we'll select that as our input. Demo RD-Kit type.stf. So here we're typing the name of the output file. We can put that in a directory if we want, and that directory will be created, but let's keep it simple. And then we've got a list of properties here that we could calculate. Let's calculate them all. And a few other parameters depending on whether the input is SDF or smiles or whatever. So now we'll run that job. And again, what's happening now is a Kubernetes pod is being fired up, and in that pod, the RD-Kit software is being invoked to calculate those properties. So let's click on that job, and we'll see its details in the results tab. So now that job is now seen as running. We get a series of events that happen as the job is created, as it runs, and as it finishes. This one runs reasonably quickly, or it should do. Okay, no, it's completed. And now we can look at the output. The options of viewing outputs at the moment are relatively limited. This is why we want to create the Squonk2 product, which will allow you to do much more effective molecular visualizations and data analysis. But you'll see here in the SD file that those properties that we specified in the user interface have been calculated and added to those molecules. So that's a very simple job. Now let's look at a more complex one. Let's look at doing some virtual screening using docking. So in the project, I have already created a few artifacts that we need to do this. I've created in this folder the protein structure of dihydrofolate reductase in a form that is ready to dock. and I've put it in. We're going to use RDoc for the docking, and I've put in the configuration files we need for that. They're basically two files we need: the active site configuration and the docking configuration file. Now we have a job that can generate these for you, but in the benefit of time, I've pre-created them in the project, and in the top level of the product, I have created where is it? This output here. No, that's not the report. It's this one. I've created using another job which queries a molecular database that we have populated in this case with data from Molport. I've queried that molecule, that database, to extract out a series of candidate molecules of the appropriate. Let's look at the queries. The appropriate number of heavy atoms, the number of restriction on the number of rotatable bonds, restriction on the log P, restriction on the number of chiral centers. So this provides a way to search that molecular database and extract out molecules that might be of interest that we want to dock. So those are the ones that we're going to use as our inputs. So let's go to the RDoc virtual screening, and it's the run job that we want to do. And we now just need to specify those files. I don't have any properties. I can't really go into far. I want the active site configuration. I'll just mark these as favorites to make them easier to find in the future. What else do I need? That's it. That's it for there. So that's the cavity definition file. I want to specify the molecules we want to dock. I need to specify the configuration file, which I now can do this way. And I need to specify the protein structure. So that's done. So we now have all our inputs. So let's put this into the output into a new directory, just so it doesn't get mixed up with other ones that I might have done previously. I'll reduce the number of dockings to 5, which is a bit low. You probably want to do 20 or maybe even up to 50 or something to get meaningful results. But for the benefit of a demo, I'll keep this a relatively small number. And now we can run it. And now what's happening is a Nextflow workflow is being fired up that runs the entire virtual screening process. It takes the input molecules, it splits them up into chunks. Each chunk is then docked in parallel on the cluster, and then when all of that is complete, the results then get joined together. And there are other jobs we can run that do virtual, to do additional rescoring functions and things like that. So now what you'll see, these events now start looking a bit more complex than they did before. And this job won't complete within the time frame of this of this webinar. It'll take about half an hour or so, maybe 40 minutes to do this docking, because we're doing, I think it's docking 100,000 molecules, I think it was, and we're doing 5 dockings of each, so it won't complete within time. But what I can do is show you what this looks like for what I did earlier. So here's the previous job that I ran earlier this morning, when you'll see it's gone through and it's split the process up into basically 100 chunks and docked each of those independently, and then collected the results together. So you get a quite detailed report of what's going on. And if you want more reports, you can look at the log files. So here are a number of logs that are created, including a quite nice report that Nextflow generates on the execution of the jobs. So it tells you how much CPU activity was used by each job, how much memory was used, how long each took. And you can see the first step of splitting the SDF is trivial. It's the docking that is the thing that takes up the computational time. So there's a lot of quite nice analysis here that's provided, but probably of more interest than the this one. Probably just to prove that we actually have done some docking here. Let's just look at the results. This takes a little while to load because the file is quite big, but it will come eventually. Anyway, while that's loading, let me do one other thing. I'll show you, and this will be the last thing we do. I show you how you would create one of these jobs and have it added to Squonk, which is not something anyone can do. You certainly need to be sort of IT savvy to do this. You need to have some programming skill, but it's certainly something that the IT people in your organization or your computational chemists or whoever should be able to do. So if you remember, we had a job that calculated properties using RDKit. So that is implemented basically as a Python module. It doesn't have to be Python. Other things run as Java. Any programming language can be used. The only requirement is that it must be packageable up into a Docker container, and pretty well everything is. So this is just a bit of Python. We're not going to look at it. It's not particularly exciting, but you have a number of basically it's a command line Python application that calculates those properties. Now, how does Squonk know how to execute that? Well, we have to create basically a job description, and that's what this is. It looks a bit scary. It's a YAML file that basically defines that defines the job execution, and this is the definition here for that molecular property calculation. And basically you have to define a number of things like how to execute the code. How does that Python file get executed? What are the options that need to be specified? So remember, we have options for each of the properties we want to calculate. So this, by declaring how your job should behave, the user interface is generated automatically. So if I wanted to, I can just quickly do that. All of this user interface is built automatically based on that job declaration. And the final thing you probably want to write is some documentation for your jobs. So you would then write a bit of information telling the user how to execute that job. Having done all that, you can then deploy that, or the administrator of Squonk can deploy that job to Squonk, and it will immediately become available. So here is the results of that docking that I ran earlier this morning. And if you're familiar with RDoc, this will make sense to you. If you're not, it'll look like gibberish. But basically, we've got a series of docking scores here that have been generated that we can go on and analyze further. So I think basically that's what I wanted to show you. So I'll leave it at that. We're just over 40 minutes in. I'm just thinking if there's anything else I ought to show. Probably not. I think I'll probably leave it at that. So thank you for your attention. If you've got any questions, then hang on in and ask them. Otherwise, thank you for your time.